Hi, Algebra 2 students. Today you're going to learn about infinite geometric sequences / series. What is an infinite geometric sequence? An infinite geometric sequence is a sequence that is geometric that goes on and on and on, dot, dot, dot. There's no end to it, okay? So today we're going to focus on finding the sum of that we're going to evaluate the series, excuse me. And to find that sum of that sequence, which is now when you're finding the sum, meaning you're evaluating the series, okay? To find that sum, the rate, or the common ratio, excuse me, the absolute value of it has to be between 0 and 1, okay? It has to be between 0 and 1. Let's go through the formula now for that infinite geometric series that you are going to evaluate, okay? It's a really nice and easy one. The sum is equal to a sub 1, okay, divided by 1 minus r. And just a friendly reminder, you can only find this sum again if this r, this common ratio, its absolute value is between 0 and 1, okay? Now, how do I find that common ratio again? I just take any term in the sequence, it doesn't matter which one, and I divide it by the one that is previous to that, okay? The one that is previous to that. All right, let's get some practice. So the question that we have right now is, can we actually evaluate the series? I'm gonna have some sequences down here that are geometric, that go on and on and on, right? But can I actually find the sum of it? So let's start with this first one. We have 2 plus 1 plus 1/2 plus dot, dot, dot. So it keeps going on. It is infinite, okay? So what I want to do first is I want to look at the ratio, okay? What is happening to go from 2 to 1, from 1 to 1/2, and so on and so forth. So again, to find that ratio, I'm going to take, it doesn't matter which number I take. I could take 1/2 or I could take 1, doesn't matter. And then I'm going to divide it by the one that is previous to it, okay? The one that comes right before it. So I'm going to take this 1 right here, okay? And then I'm going to divide it by the one in front of it, which is 2. And that gives us our common ratio there, which is 0.5. Now we have to ask ourselves the question, can we actually evaluate it, meaning find the sum? And in order to evaluate it again, that ratio, excuse me, the absolute value of it has to be between 0 and 1. Well, the absolute value of 0.5 is 0.5, so the answer is yes. We can evaluate it because the absolute value is between 0 and 1. Okay, let's go to the next one here. We have 1, then we have a -2 plus 4, then we have that negative again. It goes on and on and on. What's our first step? I just said it in this one. We find our common ratio. Again, it doesn't matter which one you take. In this case, I'll take that 4 for you just to show you how we can do it different. 4 divided by a -2, because that's the one previous to it, that's equal to -2. Now the question is, can we evaluate it? Can we find the sum of this infinite series? And the answer is no, because that common ratio, okay, the absolute value of -2 is 2, and that is not between 0 and 1, so we cannot find the sum. Okay, next, 16 -4, or 16 minus 4 plus 1 minus. Let's go ahead once again and find that ratio. Okay, so I'm going to take that 1, and I'm going to divide it by -4 to give me a -0.25. Okay, can we evaluate this infinite geometric series? Yes, we can. Why can we? Well, because the common ratio's absolute value is between 0 and 1. So the absolute value of -0.25 is 0.25, okay? So yes, we can evaluate it. Now, one thing you should check is, in this case, I told you these were all geometric, but there could come a time where you have to evaluate, is it even a geometric series? So what you would do is you'd find that common ratio like we did here. 1 divided by 2 is 1/2. And then you would just want to check, okay? You could check it a couple different ways. You could say, oh, well, 2 times 0.5 is 1. 1 times 0.5 is 1/2. That would be one way. Or you could say, hey, 1/2 divided by 1 is also 1/2. So you would, the first time when we got that rate right there, we did 1 divided by 2, which is 0.5. We can confirm that it's 0.5 again by taking 1/2 divided by 1, okay? Just to confirm that it is actually geometric. Again, I'll just state about it again. How do I know this is geometric? Well, -2 divided by 1 is -2, and 4 divided by -2 is also -2. So that common ratio is the same for both of these little humps. All right, moving on. Let's go and find the sum of the series now, or evaluate the series, okay? So we have 2, 1, 1/2, okay? Here is my formula, and always the first thing we want to do is we want to find that common ratio, right? So we did this already. This is the same one we had on the previous page, and we saw that, hey, 1 divided by 2 gives us 0.5, okay? So now we're just going to fill in what we know. A sub 1 is always the first term, so that's 2. My rate is 0.5, so I'm going to plug in 2 into A sub 1 and 0.5 into R. So there we go right there. I did that just right there, okay? Next, what I want to do is I want to evaluate the denominator. Okay, so 2 minus 0.5, that gives me 0.5, okay? And now I want to evaluate the whole fraction here. So 2 divided by 0.5, that gives me 4. So the sum of that infinite series is equal to 4. If I went too fast, I apologize. Pause, rewind, and reach out to your teacher if you have any questions about this first example. Okay, next example. We have 16 minus 4 plus 1 minus ... So it is infinite, okay? We're going to find that common ratio right now. And we really want to double check too, can we actually find the sum of this series? Now it does work on this one, but just in the future, you should double check that. So step 1 always is find that common ratio. So that common ratio is right here. I took this -4 divided by 16, which gives me a -0.25. We do know that we can find the sum. We can evaluate the series because that common ratio's absolute value is between 0 and 1. Okay, now we're going to plug in our first term into A sub 1, and we're going to plug in our rate into R. Now be careful here because we have 1 minus R, and R is also negative. So I wrote it just like this. Whenever I plug in negatives, I always like to put my parentheses there so I don't make simple mistakes. And so I have 16 over 1 minus a -0.25. 2 negatives then give me a positive. So I rewrote it as 16 over 1 plus 0.25. I now am going to evaluate the denominator. So that's going to give me 16 over 1.25. And when I divide that out, I get 12.8. Okay, I think we have one more to try. Oh, we don't have one more try. There we go. That's it. So again, just as a quick summary, what have we learned? We know that if we have a geometric sequence, if we have an infinite geometric sequence, it goes on and on and on. When we find the sum of that, we call that infinite geometric series. We can only find the sum if the R value's absolute value, okay, is between 0 and 1. All right, guys, have a great day and let your teacher know if you have any questions.